Hello, good people of planet Earth. Welcome. This is Ace of the Cosmos. Here's what's ahead. How fusion powers the sun, why the outer layers get hotter, the sun's magnetism, flares and space weather, gravity from Newton to Einstein, and how our star shapes Earth, from auroras to satellites. Have you ever truly thought about the sun? Many imagine it's burning like a cosmic bonfire, but the reality is far more exotic. The sun doesn't burn. Deep in its core, nuclear fusion powers our star, turning hydrogen into helium and releasing an ocean of energy. It's the powerhouse of our solar system, and its immense gravity holds our planet in a graceful dance of orbits. And yet, it's a rather average middle-aged star among billions. Ready to see where it gets really weird? When we look up at the sun, using safe filtered telescopes of course, we see a bright, defined disk. Astronomers call it the photosphere. It's the sun's visible surface. It may look smooth from afar, but it's anything but. A roiling ocean of superheated gas, plasma, covered in granules, each about the size of Texas. They're the tops of convection cells. Hot plasma rises, radiates, cools, and sinks again. The photosphere is blistering, around 5D 500 at C, hot enough to vaporize any known material. But here's where intuition fails. Move away from a flame, things get cooler. The sun doesn't play by that simple rule. Above the photosphere lies the chromosphere, a thin reddish rim, and beyond that, the corona, an ethereal halo of plasma. Shockingly, this faint layer is hundreds to thousands of times hotter. It's one of solar physics' longest-standing paradoxes. The secret points to magnetism. The sun is a magnetic star. Its churning plasma acts like a dynamo. Fields twist, tangle, and evolve constantly, forming loops that hold the ultra-thin coronal plasma. When magnetic energy releases, it can heat the corona. One idea: countless nanoflares, tiny, constant magnetic explosions. Another: waves, magnetohydrodynamic ripples depositing heat aloft. During totality, when the moon blocks the glaring disk, the corona emerges, a ghostly crown with streamers and loops tracing invisible magnetic lines. A fleeting window into the sun's hidden superheated realm, and that realm is anything but calm. In X-rays, the million-degree corona shines, yet with intriguing dark regions. Those are coronal holes, gateways to a wind that fills the solar system. From that superheated halo, zoom out. What holds this whole family together? Gravity. Our solar system moves to the sun's pull, each world tracing an ellipse around a shared balance point, the Berry center. Watch Jupiter tug the sun so that point wobbles in and out of the solar surface. Newton gave us the simple rule: every mass attracts every other, and the pull fades with the square of distance. That law predicts Kepler's elegant ellipses and sets orbital speeds. Mercury sprints close in. Neptune takes a leisurely stroll far out. Then Einstein refined the picture. Mass and energy curve space-time, and planets follow the straightest paths in that curved arena. Near the sun, that curvature subtly tweaks motion, just enough to explain Mercury's extra-perihelion advance that Newton couldn't quite nail. Even light feels the curve. During a total eclipse, starlight appears shifted around the sun, gravitational lensing, space itself acting like a cosmic magnifying glass. So which is right? Both. Newton steers most journeys beautifully. Einstein steps in for the extremes and high precision, and while gravity choreographs the dance, magnetism writes the drama. Next, when those fields snap, space weather arrives. The sun's corona isn't just hot, it's the source of the solar wind. Dark patches called coronal holes release high-speed streams of particles, racing towards Earth in days. These solar storms can disrupt GPS, add drag to satellites, and even stress power grids. Luckily, Earth's magnetic field shields us from most of it, but some particles sneak in near the poles, colliding with our atmosphere. The result is a direct, visible handshake with our star, the dancing auroras. These facts reshape how we see the sun. Not gentle and constant, but variable and powerful. Understanding our star isn't just curiosity, it's a practical necessity. We live inside a star's extended atmosphere. It's a laboratory for extreme physics. Every ray of light, every gust of solar wind, where I saw So SAR reminds us what makes life possible. Think of nuclear fusion in its core, roiling plasma on its surface, the mysterious heat of its corona, the invisible wind streaming past you at 1,000,000 miles an hour. Our sun is both life giver and occasional disruptor, a familiar friend and a wild, untamed beast. It truly is a wonder of the universe. When you next feel the sun's warmth, pause. Think beyond simple light and heat. Think fusion in the core, boiling plasma at the surface, 1,000,000-degree corona, and the solar wind connecting us to space. The sun is far more than it seems, a place of constant wonder. If you found this journey amazing, tap that thumbs up and subscribe for more cosmic explorations. Thank you for watching. And hey, subscribe, thumbs up, subscribe.